Perspective Class 7 Video 4. In this video we're going to do an example of parallel projection from three-dimensional space onto two-dimensional space. So let's look at the example. The example says the points -1, 0, 2, 1, 0, 2, 1, 2, 5 and -1, 2, 5 do not form a square in three-dimensional space. In fact, they form a rectangle. And here's a picture of the rectangle I've drawn in three-dimensional space. Okay, so the points are the corners and it forms a rectangle. And the question is to calculate the image of this rectangle under parallel projection onto the following planes, onto the following image planes. So let's begin with the z=1 plane. Okay, and you can imagine attempting to draw the z=1 plane like this, and what's going to happen is these points are going to parallelly project down like this, and you're going to get something. Okay, but now let's do this algebraically. So what actually happens? Well, when you're projecting onto the z=1 plane, all you do is you replace the z coordinates with 1. So 2 becomes 1. Okay, 2 becomes 1, 5 becomes 1, and 5 becomes 1. And now I'm going to plot this on the z=1 plane, which I've drawn right here. So it's the xy axes, and I'm plotting -1, 0, so that's that point, 1, 0, 1, 2, and -1, 2. So you get a square. Okay. One thing that's important to note is that the image is this square, and you can't tell just based on this image which of these points are closer to you and which ones are further away. I mean, in real life, we know that if you consider the image plane being the z=1 plane, then some points are closer than others. Like these 2 points are pretty close, whereas these points are a long way away. But based purely on the image under parallel projection, you can't tell which ones are close and which ones are far away, because parallel projection sort of it's not refined enough to take into account that sort of information. Okay. Let's quickly do some projections onto other planes. So if we project onto the y=3 plane, okay, well, all you do is you replace the y coordinate with 3. So I'm just writing 3 in all of the y coordinates. And now I'm going to plot onto the y=3 plane, which is this. The x-axis is on the horizontal and the z-axis is going vertical. And you plot. So this first point here, because I'm already assuming I'm on the y=3 plane, ignore the 3 and just plot -1, 2. So -1, 2, like that. This one here, ignore the 3, just plot 1, 2. So like that, and so on and so on. And then you get this rectangle. So it's not a square, it's a rectangle now. Okay, and this is just like capturing the fact that when you parallel project onto a plane of the form y=a number, this object, this rectangle, looks like a rectangle. Whereas if you parallel project onto a plane of the form z=a number, this rectangle looks like a square. And lastly, let's just do what happens when you parallel project onto a plane of the form x=a number. Well, if I project onto the x=2 plane, I'm just going to replace all the x coordinates with 2. That's easy enough. And now I plot. So the x=2 plane is right here. This is going to have the axes y and z. And I just plot. So this first thing here, ignore the 2, because that's the x coordinate, and just plot 0, 2. This one here, ignore the 2, plot 0, 2, same point. This one here, you're going to plot 2, 5, which takes you all the way up there. And this one here is same point up there. So viewed from this angle, the three-dimensional rectangle just looks like a line segment, like a diagonal line segment. Okay. So we're not going to go into details, but I think it's an interesting question to ask. Like, if I gave you this question backwards, if I just told you, like, this is what it looks like if you project onto an X plane, this is what it looks like if you project onto a Y plane, and this is what it looks like if you project onto a Z plane, can you tell me what the object looked like originally in three-dimensional space? So it's like, if I just give you what it looks like under each of the cardinal projections onto the X, Y, and Z planes, how much can you tell about what the figure originally looked like in three-dimensional space? Like, can you deduce that it had to be this figure all along, which made these images? Or maybe are there lots of different possible figures which will give you the exact same projections onto the three different planes? Okay, I'm not going to tell you the answer. That's the end of this video.